So, good morning class. Today we will further discuss about solid state. In the last segment we saw classification of solids. After that we saw some of the general characteristic features of crystalline and amorphous solids. Now we will further discuss about solid state in detail. So, while discussing about solids, first of all let us see what is unit cell. So, let us see what is unit cell. So, unit cell is defined as the smallest 3D structure of constituent particles, and the constituent particles can be either ions or they can be atoms or they can be molecules, which on arrangement on a definite pattern gives the entire crystal lattice. So, this is unit cell. So, unit cell can be defined as the smallest 3D structure, and the 3D structure will be made of constituent particles, and the constituent particles can be either ions or atoms or molecules, which on arrangement in a definite pattern or in a definite rule, after arrangement we will get the if, and after the complete arrangement we will get the entire crystal lattice, or it can be also called crystal, or it can be also called solid. So, unit cell can be defined as the smallest 3D structure which on arrangement in a definite pattern gives us the entire crystal solid. Now, when we are discussing about unit cell, so if we know that our crystal or our solid is 3-dimensional picture, then our unit cell should also be a 3-dimensional picture. So, we can represent this unit cell also with a cube. So, this is our unit cell. So, this is our single unit cell. So, if this is our unit cell, so we can represent the different particle arrangements, like this will be the position of particles at the corners. So, these are the position of particles at the corners. So, these are the position of particles at the corners. So, this is our unit cell. If our solid is 3D imagination, if our solid is 3D picture, then our unit cell will also be a 3D picture. And if this is our unit cell, so the location of particles will be like this, and there can be other locations also, but this is the main basic arrangement. So, these are representing the position of particles at the corners. So, this unit cell is defined as the smallest 3D structure which after arrangement in a definite patterns gives us the entire crystal or solid, or what we can say crystal lattice. So, let us discuss further. Now, let us see further what happens. So, let us now further discuss a single unit cell. So, let us further discuss a single unit cell. So, let us this be our a single unit cell, and if we expand this in 3D structure, 3D coordinate systems, like what we are doing. So, I am expanding this in 3 coordinate system or 3D axis. Let it be x axis, let this be y axis, and let this be z axis. So, after this arrangement, we will get some points, some parameters, we will get 6 parameters. So, we have edge length along A, along x axis, let it be A, the edge length along y axis, let it be B, and the edge length along z axis, let it be C. After that, we will have 3 interaxial angles. So, let the angle between y axis and z axis be alpha. Let the angle between y and z axis be beta, and the angle between y x and z axis be gamma. So, we have 3 edge lengths A, B and C, and 3 interplanar angles, that is alpha, beta and gamma. So, total we have 6 parameters related to unit cell. They can be divided into further 2 categories. The first one are edge lengths along different planes, and the edge length are A, B and C, whereas A is along x axis, B is along y axis and C is along z axis. And we have 3 interaxial angle, that is alpha, beta and gamma. So, alpha is between y and z axis, beta is between y and x axis, and gamma is between x and z axis. So, these are the 6 parameters which we derive on the basis of this arrangement. So, we have, this is our single unit cell and expanded in 3D coordinate system. Fine, let us move forward. So, this is our unit cell expanded in 3D Cartesian coordinate system, x axis, y axis and z axis. So, after this we have 6 parameters, 3 edge length and 3 interaxial angles. So, the edge length along x axis is A, this one is A, edge length along y axis is B, small b, and edge length along z axis is small c. So, this is small c and this is small b, and after that we have 3 interaxial angles, that is angle between z axis and y axis as alpha, angle between x and y axis as beta, and the angle between x and z axis as gamma. So, on the basis of these 6 parameters, we will derive the further classification of these types of unit cells. So, let us move forward. Now, types of unit cells. The next category is types of unit cells. So, basically unit cells are of 4 types. So, the first one is primitive or simple unit cell. Second one is face centered unit cell. Body centered unit cell. And the fourth one is end centered or edge centered unit cell. So, these primitive unit cells can be further categorized into 7 types. So, let us define these 7 types. Let us define these 7 types of further classification of primitive unit cell. So, the first one is cubic unit cell, second one is tetragonal unit cell, the third one is orthorhombic unit cell, next one is rhombohedral unit cell, next one is monoclinic unit cell, next one is hexagonal unit cell, and the last one is triclinic unit cell. So, these are the 7 types of further classification of primitive or simple unit cell, and these 7 types are collectively called 7 crystal system or Bravais crystal system, or they are also called Bravais lattice, because they were discovered by Auguste Bravais, which was a scientist. So, after his name, the names are called 7 crystal system or Bravais crystal system or Bravais lattices or lattice. So, this is the classification of unit cell. So, this is the classification of unit cell. So, basically let us see the types of unit cell. Basically the unit cells are of 4 types: primitive or simple unit cell, face centered unit cell, body centered unit cell, and edge centered or edge centered unit cell. So, the primitive or simple unit cell are of further 7 types, because they were discovered by Auguste Bravais, so called 7 crystal system or Bravais crystal system or Bravais lattices. And these 7 crystal systems are cubic unit cell, tetragonal unit cell, orthorhombic unit cell, rhombohedral unit cell, monoclinic unit cell, hexagonal unit cell, and triclinic unit cells. So, these are the 7 types of further classification of primitive or simple unit cell. Now, let us see what is the difference between these types of 7 unit cells which are characterized under primitive or simple unit cell. Now, let us see, let us discuss the first one, that is primitive unit cell. In case of primitive unit cell, we are going to discuss about 7 crystal systems. Now, let us discuss each and every one in detail. So, the first one was cubic unit cell. So, let us see the arrangement of different parameters. We will differentiate them on the basis of 6 parameters, that is A, B, C and alpha, beta, gamma. So, cubic unit cell is a well mannered unit cell where all the edges are equal, A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. Now, the second one, that is tetragonal unit cell. This is A is equal to B, which is not equal to C, but alpha is equal to beta is equal to gamma is equal to 90 degree. Now, the third one is orthorhombic unit cell. Now, the arrangements are A is not equal to B is not equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. Now, the fourth one is rhombohedral unit cell. In case of rhombohedral unit cell, A is equal to B is equal to C, but alpha is equal to beta is not equal to gamma and gamma is not equal to 90 degree. Next, fifth one, monoclinic unit cell. Monoclinic unit cell. A is not equal to B is not equal to C. Alpha is equal to gamma is equal to 90 degree. Beta is not equal to 120 degree. Next, sixth one, hexagonal unit cell. So, A is equal to B is not equal to C and alpha is equal to beta is equal to 90, gamma is equal to 120. And the next one, seventh one, that is triclinic unit cell, the most irregular, that is A is not equal to B is not equal to C and alpha is not equal to beta is not equal to gamma is not equal to 120 degree. So, these are the different types of Bravais lattices or Bravais 7 crystal systems. So, these are the further classification of 7 crystal systems, wherein all the 7 types are differentiated on the basis of 6 parameters, that are A, B, C and alpha, beta, gamma. So, the first one, cubic unit cell, A is equal to B is equal to C, alpha, beta, gamma is equal to 90 degree. Tetragonal unit cell, A is equal to B is not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree. Third one, orthorhombic unit cell, A is not equal to B is not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree. Fourth one, rhombohedral unit cell, A is equal to B is equal to C, alpha is equal to beta is not equal to gamma and gamma is not equal to 90 degree. Monoclinic unit cell, A is equal to B is not equal to C and alpha is equal to gamma is equal to 90, beta is not equal to 120. Hexagonal unit cell, A is equal to B is not equal to C and alpha is equal to beta is equal to 90, gamma is equal to 120 degree. And triclinic unit cell, it is the most irregular arrangement, that is A is not equal to B is not equal to C and alpha is not equal to beta is not equal to gamma is not equal to 120 degree, the most irregular arrangement. Now, let us see the second characteristic feature. So, the first one, that is primitive unit cell. We have seen the 7 types of primitive unit cell. Let us see what does the primitive unit cell mean. So, the primitive unit cell, it states that, what is this? It is a unit cell when the constituent particles, and the constituent particles may be ions or atoms or molecules, are present only at the 8 corners of the unit cell, when they are present only on the 8 corners and none else other. Like if we see the arrangement, so let this be a unit cell . So, after this arrangement, these are the 8 corners, and if the particles are present only on the 8 corners, so it is an example of primitive or simple unit cell. Primitive or simple unit cell. And what are these? These are the particles at the corners of the unit cell. So, thank you class.